Right, this is part 2, which is more geared towards the technique of how to get the decimal value of this mantissa with exponent. So this is from a recent exam, I think it's January 2013, and the mark was working mark is 1, answer is 1. And although this video in 2 parts will be close to half an hour of information, actually the technique becomes quite easy, so you can get these marks quickly. Alright, let's have a look. It's right, the normalized floating, and this is the second part we'll deal with as well. What on earth is a normalized floating point? So let's move on. Okay, we've got our 8-bit mantissa. The first thing, this is the technique, identify the parts. So mantissa, exponent. And then ask yourself, is the number negative or positive? Extract the mantissa and restore the leading 1. You may also omit the trailing zeros. So if there's any trailing zeros, you can omit them. Right, so the exponent part is indicating where the decimal point needs to be. So this indicates how many places the decimal point needs to move. This indicates how many places the decimal point needs to move. And a positive exponent means you move to the right. A negative exponent means you move to the left. I didn't know exponents could be either negative or positive. Yes, they can. And there's your little indicator. If that's a 1, it will be negative. If it's a 0, it will be positive. Alright? So, the most significant bit is a 1 for our mantissa, and it is in 2's complements. So this must be a negative number. Alright? Here we go. So 1.001 is the first thing to identify, and it's now it's our exponent. So convert the exponent. Sorry, just to make clear, that was identify the parts and identify whether the mantissa is negative or positive, i.e. is it in 2's complement. This part is now to convert the exponent, the 0010. It equals positive 2. Well, how do we know that? Remember binary. Going from the right, that's 1, that's 2, that's 4, and that's 8. So we know that it's 2. Slide the decimal point of the mantissa 2 positions to the right. 1, 2. 2 positions to the right. Okay? Alright, so let's look at our 1.001. We're moving it 2 to the right, so that becomes 1001. You say, why to the right? Well, remember, our exponent is positive. That's why to the right. If this exponent had a 1, it would be negative, and we would move it to the left. The exponent part makes us move it 2 places to the right. 1, 2. And I've sort of animated it here for you to see. Because the exponent is binary converted to decimal, it's 2. So I've called that 3.1 change binary number. Okay. Change it to what? Well, change it by the exponent, denary equivalent. The denary equivalent of this is 2. And 3.2 I've called change binary number because now it is in 2 complement and it is a negative number, so flip the bits to the left of the last 1. Okay? So that becomes a 0, that becomes a 1, that becomes a 1. Okay? And left binary equals 3. Right fraction equals 0.5. What do I mean by that? Well, this is binary 1, that's binary 2, so this binary number is 3. The right part of the floating point, there's the terminology, is binary 0.1, and we know that 0.1 is our fraction, it's half, 0.5 in other words. So the original number is a negative. Don't forget the original numbers are negative. Let's page up, because that first most significant bit was 1. And so what is our number going to be? Before I show it to you, I hope you got that. Minus 3.5. Okay, 3 and half. There's our fractional component. Okay, so we could do that in reverse, which is one of the first questions I showed you in part 1, where you are given minus 3.5 and you have to express it as binary, which would be that as the answer. The floating point number system uses 16-bit numbers, 8 bits for the signed mantissa and 8 bits for the signed exponent. Convert the following binary number to denary. Okay, this is an example question. So, step 1. By the way, I'm showing you this as a step-by-step technique now. It's exactly what we've just done, but it's showing you really broken down and really slowly. And this I found not in our textbook but online, and this was a really good technique. So I'll do the rest of this technique in part 3, so that's not overwhelming with information.